All right, this is the big video. This is the one where we go over something called factoring. So what do I mean by factoring? Before I get into what we're going to be doing specifically, let's talk about the term factoring. I want to do that by looking at just a basic number example. Let's say you have the number 8, and I ask you to factor that number. What I'm asking you to do is, can you find numbers that multiply together to give me that? So 8 could be thought of as 2 times 4. I have just factored the number 8. Furthermore, these two numbers are considered factors. They're factors because when you multiply them together, they give you 8. Right? Another example, 12. If I ask you to factor 12, well, what are two numbers that give you 12? You could do 3 times 4. So 3 and 4 are factors of 12. That means that when you multiply them together, they will give you 12. And you can do that even further. You can do, let's say, 24. You can have more than two factors. You could say, well, 2 times 3 times 4. That gives you 24. So all three of these terms are factors. And the act of separating these things into things that multiply together is called factoring. Now, this, I don't want you to confuse that with addition. So 8 could be written as 5 plus 3, but these aren't factors, right? I have broken it down as far as things that add together to give me 8, but that doesn't mean that these are factors. Factors are only going to be things that multiply. You also can't have things like this. Let's say I have this. While this is true, 2 times 3 is 6, plus 4 is 10. 3 is not a factor of 10. This is not factoring because I've got an addition in there. So when you factor things, you're trying to turn it into a group of things that are only multiplied. So something times something, or maybe three things multiplied by each other. Okay, so that's what we're going to be doing. Let's start with a very basic example. You remember in our last video, we talked about how to distribute. So we had something simple like x plus 5 and then multiplied it by 3. You remember we just did the distributive property. So I just multiplied 3 times both pieces. So 3 times x gives me 3x. And 3 times 5 gives me 15, right? Well, notice that up here, let me color code this. Up here I have something times something else. I have two things being multiplied together, and their answer is something else, right? So if I was given this, if I said, okay, I'm going to give you 3x plus 15, and can you factor that? What I'm asking you is, can you turn it into two things that are multiplied together? Well, yeah, it's this thing times this thing, right? That fits the bill, doesn't it? That's two things that are multiplied together to give me that final thing. Now, that does have addition in it, but that's inside one of those multiplication things, so that doesn't really count. It's inside one of those factors. So without getting too complicated here, the idea is undoing multiplication, undoing the act of 3 times x plus 5. Well, that multiplication, if you undo it, it'll give you this piece up here again. Okay? So, for instance, let's say I gave you 5x plus 20, and I said, can you factor that? In other words, can you turn this thing into something times something else? Well, if you think about it, and you look at this as a pattern, you could say, well, it looks like this 5x plus 20 was probably created by multiplying something times these two pieces, right? And what was that number? Well, it was probably 5. Why? Because 5 can divide evenly into this and into this. So really what you're doing is you're looking and saying, can I divide something evenly into this and into this? Because if you can, then you can unmultiply it, right? You can divide it out. So if I pull that 5 out, I'm saying this was probably a 5 out front. And if I divide out a 5 out of 5x, what's left? An x. And if I take a 5 out of 20, what's left? It's a 4. I have just factored this binomial, this 5x plus 20 thing. By pulling a 5 out, I have factored it out. So now I have something times something else. All right, let's try another one. Let's do 6x plus 18. All right, so I'm going to ask myself, if I want to factor this, is there something that was multiplied by this thing to get this thing? That's kind of a weird way to say that now that I say it out loud. But is there something I can divide out? And there is. Notice that 6 will go into both 6 and 18. So I'm going to divide 6 out and pull it out front. So if I divide 6x by 6, I get x. In other words, I just remove the 6. And if I take 6 out of 18, in other words, I divide 18 by 6, I get 3. So I have undistributed or factored 6x plus 18 into 6 and x plus 3. All right. Let's try another one. Let's do 2x minus 10. Try that one real quick. Okay. So notice this and this both have a 2 in them. And when I say in them, I mean they are factors of both of them. They are inside that number. You can divide it into that number evenly. So if I divide both the 2x and negative 10, I get x minus 5. All right. Now these examples are very simple because so far I'm basically just taking this first number, put it out front, and then divided the second number by that. But it doesn't always work that way. Let me show you what I mean. This is why you need to have a little bit deeper understanding of what's happening and not just stick the number out front. Let's say I gave you something like this. And I said, I want you to factor that. Well, if you're just trying to follow the pattern that you just saw, you might say, okay, well, let's pull a 6 out. And then I put a 6 here, x here. And then if I divide 10 by 6, well, you could do that, but you get a fraction or a decimal, and that's gross. Nobody wants to do that. What should I do instead? Well, remember the goal of this. The goal of this is to have something times something else. It doesn't matter what this number is necessarily, but is there something that I can pull out of this? Something, in other words, something that divides evenly into both of those things. Well, just a little bit of thought would tell you that a 2 will go into both of those things. I know you can't tell. I'm trying to erase this dot furiously. It's just not erasing. Hang on a second. This is going to drive me crazy. Maybe you try it this way. There it goes. Okay. So I can divide both of these numbers by 2, which means I can divide a 2 out. So if I take a 2 out of 6x, what's left? 3x. I've just divided it by 2. And then if I divide the 10 by 2, I get 5. Now, if you don't believe me, or you're not convinced, or you don't like it, or it makes you uncomfortable, I suggest just multiplying that back out. What you can do with any of these, you can always just multiply it out and see if you got the original answer. And if that's the case, then you did it right. Either that or you messed up the multiplication and you did 2 wrongs. But hopefully that's not the case. All right, let's do another one. Let's do 10x plus, I don't know, 25. All right, you try this one real quick. Okay, same concept. You can't just stick a 10 out front because then you'd be dividing 25 by 10. And while you can technically do that and get a decimal or a fraction or whatever, the whole goal of this is to get whole numbers over here, as you'll find out later the reason why we're doing this. But anyway, let's find a number that divides evenly into those. And specifically, let's find the largest number that does that. Well, in this case, there's only one number that divides evenly into both of them, and it's 5. So if I pull 5 out of the 10x, I get 2x, and I pull 5 out of that, I get 5. And again, if you multiply these out, 5 times 2x gives me 10x, and 5 times 5 gives me 25. So working backwards or forwards, however you want to think about it, multiplying back through will give me this. So that means that I did do the factoring correctly. All right, let's do a couple more before we make this more interesting. How about this one? Now, looking at this, you might be tempted to say, well, I can pull a 2 out, and you want to leave that negative there, but kind of thinking ahead, I know you don't know this, but thinking ahead to what we want to use this for, whenever you have a negative out front, you want to pull that out with whatever you're doing. So while you could just pull out a 2, it's useful to pull out a negative 2, so the entire piece here. So let me show you what that looks like. If I pull a negative 2 out, well, if I take negative 2 out of this piece, what's left? X. And if I pull out, or if I divide negative 10, let me actually do that. Negative 10 divided by negative 2. Well, it's a negative 10 divided by negative 2. That's a positive 5, right? Negative divided by negative is a positive. So that's going to give me a positive 5. So be careful as you pull out negatives. In other words, when you undistribute a negative number, it's going to change whatever signs are inside that parentheses. That's what that does. It flips them back because you're dividing by a negative number, right? So, for instance, let's do another one. Let's do negative 3x plus 18. So something like this. Again, you could just pull out a 3, but with our thoughts moving forward to what we're going to be using this for, which again you don't know yet, we're going to go ahead and pull that negative as well. So it's a negative 3x. If I divide 18 by negative 3, what's 18 divided by negative 3? That's a negative 6. Now, you don't have to write this piece out here if you don't want to. The way I really think of it is whenever I pull a negative out front, or I factor out a negative anything, I just flip all the signs of everything I write in here, because that's what's happening, right? You're dividing by a negative number, which flips all those signs. This also works if there's not a number out front. How about something like this? We'll just use a really simple example here. Something like this can be factored. It may not look like it because you don't really have any number out front or anything like that. It almost looks like something you can't do anything with. But you can factor this. This is something you can factor because remember, this is a negative 1 out front, isn't it? So you can technically divide everything by negative 1. So we're just going to pull a negative 1 out. Well, when I do that, I'm dividing by negative 1. I'm just switching all the signs. So it may not look like you can factor this because there's not much going on, but you can. As long as there's a negative in front, you can pull that negative out and it becomes a negative 1 times that stuff. So you have technically factored because you have a negative 1 times x minus 3. And again, whenever you see a negative out front, you always want to do this for the applications we're going to be using this for. So, for instance, let's say you have negative x plus 5. All right, so when I do that, I'm going to pull the negative out, and I have x minus 5. Or if I have negative x minus 6, I'm going to pull the negative out, and it's x plus 6. So when I pull the negative out, remember I'm dividing by negative 1, which changes all the signs on the inside. Okay, more examples. What about something like this? Now, in this case, I don't have a number out here to pull out, right? But I do want to factor it. In other words, I'm again going to keep reiterating, I want to find something that I can multiply times something else to get me this. So I want to divide something out. So one strategy would be usually to find a number that goes into both of these, but there isn't a number that goes into both of those. But there is something in common. And that's a thing I'm going to keep saying a lot. If you can find something that's in both of these, it doesn't have to be a number, it could be a variable. If you can find something in both of them, you can pull that number out, right? So since x is here and x is here, I can divide it away, right? So if I take x out of x squared, what's left? In other words, if I start with two x's, x squared, and I take one of them away, what's left? The other one. That's what that means, right? I've unmultiplied x times x. Now, if I pull the x out of 5x, if I divide the x away, I'm just left with 5. Now, if you don't like that, again, I highly encourage you to, well, you know what? Let's just do it. If you were to multiply this out, this is x times x, which is x squared, and then x times 5, which is 5x. It does work when you multiply. We're just thinking about how to undo that distribution. And how did you know that there was an x that was distributed? You know that because there's an x in both pieces. So if there's something in both pieces, you can pull that out. You can only pull the x out if there's something in both of them. This is very, very useful skill. This is going to come up time and time again throughout the entire algebra course, over and over. So really need to get used to recognizing when there is an x in everything and then being able to pull that x out front. So let's do a few more of those just to get comfortable with it. So let's say x squared minus, let's do 6x. Why don't I give you a few of them to do on your own? And that way we're not just waiting one at a time. Let's do a compound. Well, let's do with a couple of different steps in here. Something like that. And then how about this? All right, pause the video, try these three on your own, and then come back and we'll do them together. Okay, here we go. The first thing I'm going to notice is that if I want to factor this, I have to pull something out of both pieces, right? And I can't overstate this. You can't pull an x out unless there's an x in both pieces, right? But there is an x in both pieces, therefore I can pull an x out because it's there. So here's my x, I pull it out. If I take an x out of x squared, there's an x left. If I pull an x out of negative 6x, there's a negative 6 left. It's really that simple. All right, the next one's a little bit more involved, but not really. You're going to notice that there's an x in both of them, right? Let me actually color code this. I'm going to slow down a little bit. There's an x in both, right? But there's also a 2 in both. How do you know that? Because there's a 2 and 14 can be divided by 2 evenly, right? So in this case, not only can I pull an x out, I can also pull a 2 out. So I'm going to pull both out. I'm going to pull 2x out. So when I pull 2x out of 2x squared, what's left? In other words, what would I multiply 2x by to get 2x squared? Well, the only thing left over is x. Now think about that for a second. Before we go on, think about the fact that if I do multiply 2x times x, I will get 2x squared. That's why when I pull 2x out, I am left with that singular x. All right, now let's take 2x out of this. In other words, let's divide this by 2 and by x. If I divide negative 14 by 2, I get negative 7. And divide x by x, I get 1. It just goes away. So I remove that x. And again, as you're doing these, if you're not comfortable with them, or even if you are just kind of getting comfortable with them, multiply them back through. Just make sure, double check that you are getting this original problem when you do them. All right, let's do this one down here. Now, there's not a number out here like there was in the last one, but you do notice, hopefully, that there is an x and there is a negative out front. So remember what I said about negatives in front. You're going to want to pull that negative out every single time. All right, so I'm going to pull a negative x out because there's an x in both terms and there's a negative out front. So I pull a negative out of the front and an x out of the front, I get x left. Take a second to think about that, right? Negative x times x is negative x squared. So that does give me this piece. So that means that I did that properly. Now, if I take an x out of the next piece, that gives me a 5, but I'm also taking a negative out, right? Which means I'm switching the sign. So that gives me that there. Okay. That should be enough on this variation of factoring. This is basically just undoing distributing, right? If you were to distribute one thing into two pieces and then undo that, that's what we're doing here. But that's not the only thing you can do when you're multiplying polynomials, right? In the last video, we did a whole lot more than that, didn't we? We did things like this. We did stuff like, I'll give you an example, x plus 3 and let's say x plus 5. And we multiplied those together, right? So what if you wanted to undo this process? Well, before we get into undoing that process, let's do it forward so we can try and maybe get some clues as to how we might go about doing this process backwards. So just to clarify, we're going to multiply this out and get an answer, and then use that process to figure out how to go backwards. All right, you'll see what I mean. Okay, let's go really slowly through this. This is what we did in the last video. Hopefully you're good at it by now. So I take this x and I distribute to this and this. So I have x squared plus 5x, right? And then I take this next piece here and then I multiply times that and then times that. So that's 3 times x is 3x. And then 3 times 5 is 15. And then what we did was we said that if you look at the middle two terms, those are like terms. Those are things that are the same. So I've got 5 x's and 3 x's. How many x's do I have in total? I have 8 x's. And then I have my x squared out front. And I have my 15 in the back. Let me change this to this. Okay. That's what we did last time in the last video, multiplying through. You can also think of it as FOIL, right? That's the name of the method. If you do 2 times 2, or 2 pieces times 2 pieces. What we're going to try to do here is take something that looks like this already, right? So I'm going to give you one of these, and we're going to run this step backwards and factor it. And again, remember, factoring means I want 2 things or more multiplied together. And that's what this is going to be. It's going to be, when I undo it, not to make this too convoluted, it's going to be this thing times this thing. Even though they have pluses in it, it doesn't matter. It's 2 things multiplied together to give me this. Okay, so we're going to undo this process. This is really not that bad. Let me get rid of some of my colors here. Okay. Let's first of all think about the goal. The goal is to get this number and this number in those spaces where they belong. Well, how do those numbers show up at the end? Well, we know that this 15 here comes from those 2 numbers, doesn't it? This 15, this number at the end, comes from 3 times 5, doesn't it? That's where that comes from. You can actually trace it back. It goes here and then back that way, right? What about this number here? What did this represent? Well, this number was these 2 numbers up here, but also added together, right? So this came from 3x and 5x, which is just these 2 numbers here, right? Just added together, okay? So really, I'm looking for something that multiplies to give me this thing down here, this 15, but at the same time adds to give me 8x, because that's what this 3 and this 5 does. I hope that made some sense. So let me give you an example. Let's do one over here. I'll leave this over here just to kind of look at it, I guess. I don't know if it'll do any good. But... So let's start with something like this. And we're going to move through this one backwards. Okay, oh, that's not going to work. That makes more sense. Okay, I don't use notes again or have any kind of examples in front of me. So as I do this, I'm having to work these problems out forward or backward, however you want to think about it, in my head as I write them. So hopefully they all work out. So bear with me. Okay, so what I'm looking for are 2 numbers that multiply to give me 21, right? Just like over here we got 15. But also they're going to have to add together to give me 10. Can you think of 2 numbers that do that? Well, in this case, it shouldn't be too hard, I hope, because 3 times 7 gives me 21, but 3 plus 7 gives me 10. So because that's the case, my 2 numbers are 3 and 7. And you're done. It's that simple. At least, well, for this example, or things that look like this, right? Okay, but it's really not that bad. And these 2 questions are going to keep coming up over and over and over. So as you're doing these factoring problems, I want you to always remember this key thing. What multiplies to give me this, but adds to give me this. And if you can remember that, then you'll be able to factor pretty much anything that's factorable. All right, let's do about 1,000 more of these. Here we go. Speaking of, whenever you think you have the hang of this, that is wonderful. I want you to feel confident. But at the same time, I don't want you to quit the video early, even if you have to stop, because this is going to be quite a long video. If you have to stop and take a break, make sure you come back and watch the whole video, because even if you're feeling confident, I'm going to show you a lot of variations towards the end, which you're going to need to see all of. Okay, so even if you've got, maybe I should finish this problem. Even if you understand how to do the first few variations we do, please know that towards the end, I'm going to show you a whole bunch more variations, and you need to be familiar with all of them to be proficient at this skill. Okay, so I suggest trying this on your own. I know you just did one already. It was your first one, but give this one a shot. See if you can do it. Come up with two numbers that multiply to give me 12, but add to give me 8. All right, so shouldn't be too much effort. Well, let's actually try this. What's 3 times 4? 3 times 4 is 12. So you might have thought, okay, 3 times 4 gives me 12. But you also have to check whether it adds. So 3 plus 4 is not 8, is it? It's 7. So even though 3 times 4 is 12, that's not going to be what we need. What about 2 times 6? Well, 2 times 6 is 12, and 2 plus 6 is also 8. So that's going to be the two numbers we need. And there you go. Done. All right, let's try another one. X squared plus, let's say, 11x plus 24. I like this one. Try this one real quick, and then come back and we'll see if you got it right. Okay. So 24, I like 24 because there's so many things that multiply to give me 24. And this is good for factoring, for testing your abilities. So 24, there's 6 times 4. That gives you 24. There's 2 times 12. There's 3 times 8. There's 24 times 1. Sometimes that's useful to do the times 1 thing, which you'll see there'll be lots of those like that. Well, let's check some of these. What's 6 plus 4? 10. 10 is not 11. Remember, we have to check to make sure with the middle number too. So that's out. All right, what's 2 plus 12? Not 11. That's out. What's 3 plus 1? 3 plus 11. I can't talk. 3 plus 8 is 11. So that means that, oh, what happened to my paper? My digital paper. It's trying to escape me. Okay, because 3 plus 11, oh my gosh, 3 plus 8 is 11, and 3 times 8 is 24. That means these two numbers are our numbers. It is too late. I can't think anymore or talk. Okay, so that's how that factors. Let's try the same thing, but let's start introducing some negatives. Don't be scared. It's really not that bad. Let's do negative 9x plus, let's do 14. All right. I don't want to keep saying this, but I'm going to keep saying it. Pause it, try it on your own, and then I'll do it for you. Okay. So here we go. I picked one that's pretty simple because I didn't want a whole bunch of different options for multiplication. Really, the only options you have for 14 are 2 and 7, and 14 and 1. Well, 14 and 1 doesn't give you 9 at all. 2 and 7 kind of does. Think about it. What's 2 plus 7? Well, 2 plus 7 is 9. Is this 9? No. Do not be fooled. This is not 9. What is this? This is negative 9. Okay, so we can't just use 2 and 7. That doesn't work. But if you think about it, my goal is to multiply two numbers together to give me 14. But if you want a positive number when you multiply, you could multiply two negative numbers together, right? So if you did negative 2 times negative 7, that would give you 14, right? It still would. Negative times negative is a positive. And if you add negative 2 and negative 7, you will get negative 9. So it turns out that this is going to be your answer for this particular problem. X minus 2 and x minus 7. Right? So you can think of it this way. Whenever you have a plus here, it means that these signs are going to be the same. All right? So if this sign is a plus, then both numbers are either going to be positive, or both numbers are going to be negative, because either way, when you multiply them together, they're going to give you that positive number. So if you like rules, if you like following step-by-step rules, you can write that down. You could say, if this number is positive, both the signs are the same. And furthermore, that sign will be this one. Okay. Now, I don't really think of it that way. I think of it more kind of a guess and check sort of way. I think, hey, for that to be positive, they both have to be the same because negative times negative is positive. But if you want to think of it as just a rule, that's totally fine too. Let's do another one like that. X squared, let's see, minus, let's do 13x and plus 36. Okay, try this one on your own. All right, 36 is a good one. There's a lot of things that multiply to give me 36. Let's see, what gives me 36? There is 2 times 18. There is 3 times 12. There is 4 times 9. And let's see, well, there's 36 and 1. 6 times 6, I forgot that one. There's all kinds of things that give me 36. But remember, we're looking for things that combine to give me 13. And I'm going to notice again that since this is positive, they're all going to be either plus, in other words, both numbers are going to be positive, or you have the option of both of them being negative. And in this case, they're both going to be negative because that's how I'm going to get that negative 13. So all of these signs over here are going to have to be negative, right? Whatever it is. All right, let's think through this. Which of these pairs of numbers gives me negative 13? Well, you probably already found it. It's negative 4 and negative 9. So that means that x minus 4 and x minus 9 give me this. Okay? And I highly, highly suggest when you finish doing any factoring problem, whether it's something that was easy or you had to think a lot about, whatever the factoring problem is, I highly suggest taking an extra 3 seconds and multiplying them out in your head really quick just to make sure that it does give you, in fact, these numbers up here. So just really quickly, what I would do is I would say negative 4 times negative 9 is positive 36, and negative 4 and negative 9 added gives me negative 13. Just that extra 3 to 5 seconds of thinking and checking and making sure it does, in fact, give me these numbers can make all the difference in the world when you're doing these. Because these can be tricky as you're thinking about these negatives, and it would be a shame to miss a lot of problems because you didn't take a few seconds just to check your multiplication or addition. Okay. It's also worth noting that it doesn't matter what order you write these in, right? I could have written x minus 9 and x minus 4. That's perfectly valid too. So if you're watching the video and you're getting them backwards from me, please know that it's totally fine. There's nothing wrong with writing those backwards because you think about it, 3 times 4 is 12 and 4 times 3 is 12. It doesn't matter what order you multiply things in. It's called the commutative property, right? Does not matter. Okay, I've rambled enough. Let's do another one. This is going to be a good one. Let's do, let's see, this one. This one's a little bit more tricky. But before you watch me do it, I really highly suggest, as always, try it on your own, see if you can do it. And then test it on your own to see if you get this. And then watch me do the solution. Okay, here we go. I need to come up with 2 numbers that multiply to give me 15, but add to give me 2. That doesn't really make much sense, does it? I can't think of anything off the top of my head. But if you notice, I'm actually not trying to make 15, am I? I'm trying to make negative 15. How do you multiply 2 numbers together to get a negative number? The only way to do that is if one of them is negative and one is positive. So really, I'm looking for a positive number and a negative number. So let's try this. The first thing that comes to mind when I think of 15 is 3 and 5. So 3 and negative 5, or negative 3 and 5, either way. The point is, if you have a negative here, now again, you can think of this as a rule if you'd like, or just think through the logic so you don't have to memorize the rule and mess it up. But if there's a negative here, that means that the multiplication had to have one positive and one negative. So let's think about how this goes. If I have 3, where's my pen? 3 and a negative 5, that's 3 minus 5. That's a negative 2. Is this negative 2? No, it is not. This is positive 2. So that means this first thing that I wrote down is not correct. So this doesn't work. But what about this one? What about 5 and negative 3? That's 5 minus 3. Well, 5 minus 3 is a positive 2. That means that this is my solution. Just like that. Now, things like this, where you have one positive and one negative, can be very tricky. So again, please take a second and just check it. So negative 3 times 5 is negative 15, so that's good. And a negative 3 plus 5 is a positive 2, and this is indeed a positive 2. So I know that this, in fact, is my solution. All right. Okay, let's do, I'm going to give you like 2 or 3 more here, just off the top of my head. And try these on your own, because you really do need to get good at these. And then we'll talk about some other variations you could see. Let's see. Okay, try those out real quick, and then come back for the solutions. All right, let's do this. All right, first one. What multiplies to give me negative 28? Again, the rule being, if this is a negative, you know that one is positive and one is negative. So really, you're thinking what two numbers kind of think of it as the two numbers subtract, really, to get 3, right? It's a positive and a negative number, and you combine them, it's like subtraction. So what multiplies to give me negative 28 but subtracts or adds with the negative to give me 3? Well, what I would choose would be 4 and 7. So I'm going to go ahead and put my 4, my 7, and my x's. Which one needs to be positive and which negative? Well, this number is, this middle number is positive. You see that as a positive 3, which means if you want this to be a positive 3, the larger number over here needs to be positive, so that when you subtract the smaller number, it's not going to make it negative, if that makes sense. So if that didn't make sense to you logic-wise, just try both ways until you get it. But 7 minus 4 gives you a positive 3. That's how that works. All right, let's do this next one. Again, it's no mystery why I chose these the way I did. These all have negatives here, right? So one's positive, one's negative, and they're going to combine to give me a negative 2. That's going to be 7 and 5. Now, in this case, this is a negative number, right? So you want that negative to go with the larger number, because it's going to subtract from a smaller number and make it negative, right? So that means that if you take a smaller number, the 5, and subtract a larger number, the 7, from it, you get a negative number. That's how you get that negative 2. Again, you don't have to think that deeply about it if you'd like. If you don't want to, just, you could think of it as the larger number gets that sign. Or you could just try both of them and see which one works. So you can test and say, okay, I know negative 7 times 5 gives me negative 35, and negative 7 plus 5 gives me negative 2. Just check it, make sure it works. All right, let's do the last one. All right, I have negative 20. What multiplies to give me negative 20? But, well, what's going on here? Well, remember, this does have a number. There is something here. What is this number? It's really 1. So I'm looking for numbers that subtract, right? Because this is a negative. I'm looking for numbers that subtract to give me 1. In other words, I'm looking for numbers that are one number apart, right? It's like 3 and 4, or 4 and 5, or 5 and 6. That's kind of how I think about this. Well, what is 4 times 5? Well, 4 times 5 is 20. Those are one number apart, which means when you subtract them, they're going to give you 1. All right, so which one's going to be the positive and which one's going to be the negative? Well, this is a positive x, which means you want the bigger number to have the positive, so that when you subtract it, it doesn't make it negative. All right. Now, as should be your custom, you should check this really fast, even if you're really confident. So I'm going to check it real fast. Negative 4 times 5 is negative 20. And negative 4 plus 5, in other words, 5 minus 4, is indeed 1. Positive 1, to be clear. Okay. Let's try another one. Let's do something like this. How about this one? All right, now you may not want to try this one on your own yet. If you want to, you can, it's fine. But I would suggest just watching me do at least this first part. Now, whenever you have a number out front, things get more complicated. And there are other types of ways to do this. And in this video, we're not going to go into that in depth. We're only going to talk about one type of problem where you're going to see a number out front. And that's the type where you can pull that number out of all three of these. So this is really two factoring problems in one. So whenever I show you one of these, at least in this video, if you have a number out front, you're going to be able to pull that out or factor that number out of everything. Okay. Remember back to what we did at the beginning of the video where you tried to find something in common? Well, this 2 is going to be in common in all of them. So what I'm going to do is I'm going to go ahead and pull this 2 out of everything. Okay. So if I pull a 2 out, what's left? X squared plus, now if I divide 14 by 2, I get 7. Divide 12 by 2, I get 6. And I have this one. All right. So once you do this, then it just becomes a problem like any of the other ones. So if you haven't tried this one yet, pause it. This is a really good one. I would definitely try this before you see me, the solution for this one. All right, so a lot of students also will forget, you have to bring this 2 down. It doesn't do anything. You've already factored it out. This 2 has done its job. It is now sitting out front, but you do have to write it. You can't forget to put this 2 right here. It's still there. Okay, because if you don't put it there, it's changed the problem. But you need to have it there. It doesn't do anything. You've already removed it. It's just going to hang out. It's really easy. Just don't forget it. All right, I got my x and my x. What multiplies to give me 6 and has to give me 7? Well, 2 times 3 is 6, but 2 and 3 does not give me 7. But a lot of people don't remember. They won't think about the basic one, times 1, right? That's a valid choice, right? 6 times 1 is 6, and look, 6 plus 1 is 7. So that's my solution. So this entire thing, including the 2, is going to be my solution. So when you have a number out front, the first thing you're going to check is, can I pull that number out of everything? And then factor it as usual. Now, there are problems where you can't do that, but I'm not going to be introducing those in this video. We might visit those later on in the course if the need arises. Okay. Speaking of things like this, let's try this one. Okay. So remember when I said earlier in the video, I said, whenever there's a negative out front and you're factoring things, you want to pull that negative out. That is just as valid here. It is so important. Because the methods we're using to check multiplication and addition when you're factoring aren't going to work, at least not easily, if there's a negative out front. So what we want to do whenever we see a negative out front is to divide that negative out, just like we did at the beginning of the video. Again, every single time you see a negative, please pull that negative out. And don't skip this step. I highly encourage you not to skip this step. Don't pull it out and then just try to think, oh, I've flipped the signs. Actually write this down. It'll make your life a lot easier, I promise. So pull that negative out. You have x squared minus 5x and then plus 6. So what's really happening is I'm dividing everything by -1. But practically, functionally, all I'm doing is just sticking the negative out front and then changing all the signs, right? That's what is practically happening. Okay, now I'm going to think of 2 numbers that multiply to give me +6, but add to give me -5. So again, just like that 2 in the last example, you have to leave that negative out there. If that negative is not there, it is not correct. Okay, you have to leave that negative or it changes the problem. All right, What multiplies to give me 6? Well, this is going to tell me that both numbers are positive or both numbers are negative. But this is going to tell me automatically that they're both negative, right? So I'm going to have -2 and -3. Because, again, we're going to check -2 times -3 is +6. -2 and -3 added together will give me -5. All right, let's talk about another variation. This is a really special one. This is one that you're going to see a lot of in my course, and they show up everywhere in the rest of Algebra 2 and in other courses. This is a very, very special case of something that you'll see it a lot, and so I want you to really take care to memorize what this looks like, okay? So I'm going to give you this example here. And it looks a little different, right? Usually, so far, we have, like, say, x squared, and we have something in the middle, and then we have a number on the outside, right? But in this case, we have something where the middle term is missing. Now, don't confuse this with something like this. Let me show you this real quick. I don't want to make this too confusing. This is different. You see this? We did this at the beginning of the video. This is where you pull an x out because there's an x in both. So you pull an x out, and you get x minus 9. Call it a day, right? Do not confuse what I just wrote up here with this thing. They are very, very different. This one at the bottom had an x in both, so I could pull the x out, so I did. That's what that is. You're not going to, don't try to make up things. Just look at this and pull the x out and then write what you see after you pull the x out. But what I've written up here at the top is very different. And I need you to be very aware of that difference. Be very, very careful. Really what's happening is, if you think about it, because there's nothing here, you could think of it as a 0, like a 0x. So what I'm really trying to do is think of two numbers that multiply to give me -9, but when they add together, they give me 0. In other words, they cancel each other out. Well, the only way to cancel things out when you add is if you add and subtract the same number, right? Like 2 minus 2, or 3 minus 3, or 4 minus 4. In other words, 2 plus -2, 3 plus -3, 4 plus -4. That's what's going to cancel this mess out in the middle. Well, what's -9? What numbers will multiply to give you -9, but add together to give you nothing in the middle? If you think about it for a second, what's 3? -3 times 3 gives me -9, and -3 plus 3 gives me 0. They cancel out, right? So, whenever you see something x squared minus something like this, you're going to put this down. That's the solution. Now, I want you to understand the logic here. The logic is this times this gives me this, right? And then this plus this gives you nothing because there's nothing in the middle. But as you do this over and over and over again, you can memorize the pattern. The problem with memorizing it is, and you just have to be careful, because I've memorized it, but the problem is when you see this, you might recognize it as one of those other ones that I showed you a minute ago and do something wrong. So you have to be very careful that it's an x squared minus and something you can take the square root of. Something times itself gives you that number. Let's do another one. So x squared minus, let's say, for instance, 36. What multiplies to give me -36, but adds to give me nothing? Well, it's 6 and 6. And notice this will only work if these two numbers are the same, which means this has to be what? A perfect square. Oh, that's not even the word square. Let me write that again. Let me at least do a little better job of writing. What do I mean by that? Well, it means perfect squares are things you can take square root of, like 1 and 4, 9, 16, 25, 36, 49, 64, 81, blah, 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 blah. These numbers are so important. If you don't recognize those numbers, I would take some time, study that list. You need to know the numbers that are the result of squaring something, right? 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5, and so on and so on. Because when you see those numbers in this position, you immediately will do this. You don't have to think about it, right? So for instance, let me leave that list over there. See if I can get rid of all this stuff without getting rid of my list over there. Whenever you see x squared minus one of those numbers, you should automatically know what to do with it. X squared minus 25, that's x plus 5 and x minus 5. Done. X squared minus 4, that's x plus 2 and x minus 2. Done. X squared minus 49, x plus 7, x minus 7. Done. X squared minus 64x. Wait, stop. This is not the same, is it? Why is this not the same? Because this has an x in both of them. So if you see something like this, it's not the same, is it? So you'd pull an x out of this and give me that, right? That's the solution. So something like that. Now, if I didn't write that, I know it was kind of tricky. That was kind of messed up, wasn't it? But if I got rid of that, if I were to erase that x, oh, it didn't work. If I erase that x, it becomes like one of these others. Now, yes, in fact, it is x plus 8 and x minus 8. That's how that works. So whenever you see a term like that, x squared minus a perfect square, you'll get that. What about, like, say, x squared plus a perfect square? What about this? Let's say x squared plus 25. Oh. Well, if you think about it for a minute, you have to find two numbers that multiply to give me 25 but cancel each other out. Well, that's 5 times 5 or negative 5 times negative 5, right? Because it needs to give you a positive number. 5 and 5 are not going to cancel each other out if they're the same sign. So it turns out that this, what happened to my page? This thing is not factorable. At least as whole numbers. Technically, if you're really advanced and you can technically factor this, but it's not going to give you whole numbers, and it's kind of a whole deal. Don't read into that. Point is, for our purposes in Algebra 2, we are going to say it is not factorable. I felt like I should say that just to say that if someone's watching this and later on down the line you find out that it is, I didn't lie to you. It's just in this context, for whole numbers, it's not. Okay. All right, let's do a few more examples with that kind of special case here. Let's do something like this. Oh, not that. This. Now remember, whenever you have a number out front, and the case in the problems I'm going to give you, I guarantee you're going to be able to pull something out. And what is that number going to be? Probably the number out front. So let's see if we can pull a 2 out. Can I divide 2 into both of these? I sure can. So I'm going to pull a 2 out, just like I did at the beginning of the video. So I'm just undistributing that 2. And now I have factored it, but I haven't finished. Because if you notice, this thing looks just like the things we did before. So whenever you see x squared minus a perfect square, you're going to automatically do this thing, right? Make sure one's positive, make sure one's and the other one's negative. And again, the 2 stays out front. So you don't always start with this thing. Sometimes it's created by pulling the numbers out, and then it just kind of shows up in the middle of things, and then you can go from there. But you never want to leave it that way. You want to go ahead and factor it. All right. Along the same lines, let's say I have something like this. Okay, negative x squared minus 9. Again, not 9, this one, plus 9. Remember, whenever you have a negative out front, you always want to pull that negative out. So if I do that, well, look, now it becomes something I can factor, because remember, you couldn't factor it if there was a plus there. But now when I pull that negative out, it changes the sign, and then you're going to recognize, oh, I know what this is. It's x plus 3 and x minus 3. I know how to do that. Instantaneously, you automatically recognize 9 is a perfect square, so you put plus 3, you put minus 3, and you're done. All right? Don't forget to continue doing these. Same thing with something like this. Negative 2x squared plus 72. All right. Again, when you have a negative number out front, or a number or a negative, anything out front, pull it out first. If you divide 72 by negative 2, you get negative 36. Now, a lot of times you can just stop there, but in this case, you're going to recognize, hey, I know what this looks like. It's an x squared minus a perfect square. Therefore, I have x plus 6 and x minus 6. Okay, we've covered a lot of factoring in this video. We talked about how to undistribute basic ones. We talked about how to find two things, multiply together to get the last one to add in the middle. We talked about how to pull things out from the front, like negatives. Always remember to pull the negative out. And we talked about this special case where you have x squared minus a perfect square. This is going to cover most of the things you can factor. Of course, factoring is a massive subject. You could keep going on and on and on, and it gets more complicated and larger things you can factor. But for our purposes, I think this is going to be sufficient because the whole goal of this, here's kind of the punchline. The whole goal of this is to factor so that we can use these things, this method or these factored pieces to graph. So really that's where we're going. So in the next video, I'm going to show you how to graph things like this and you know, well, not that, but all the other ones that we've done throughout this video. If you can factor it, it's going to give you some very important, powerful information that's going to allow you to graph them very, very easily. So that's kind of where we're headed. All right. Thank you so much for sticking with me through this entire video. I hope it made sense, and I hope I wasn't going too fast. Hopefully you got a lot out of it. If you're trying to study factoring, I highly suggest doing a lot of practicing. Some things you can pick up pretty quickly, but factoring comes with a lot of experience and a lot of practice. So for my students, I'm going to give you a few worksheets to do. But if you're just watching this on YouTube, I highly encourage you to watch more videos from someone else, or find worksheets online, find content, and practice and practice and practice this stuff, because factoring is such an important skill to have as you go through your math career. It never goes away, no matter how advanced you get in mathematics. It doesn't go away, it doesn't disappear. And the more you see, the better you get at it. And it's just such an important skill to cultivate and to be good at. Okay, again, thank you for sticking with me, and I'll see you in the next one where we learn how to graph these things.